So our course title is Computer Technology. Our course code is CTE 431. So uses of ROM. As stated earlier, content stored in ROM can only be read, but in few cases it can only be edited with difficulty. As we said earlier, that for you to modify data on ROM, you have to buy a ROM burner so that you'll be able to use it in order to have access to modify those data and information on them. So for that case, ROM is used for updating firmware. If you are hearing the word firmware for the first time, so the firmware is nothing but software designed to operate basic operations like startup, communication with other devices of the system. So they have implement this policy on firmware that control the hardware and provide communication like booting of the system and so on. So it is simply data stored on your computer's ROM to give instructions on how to operate the devices. So the user cannot delete or change firmware without the help of special programs, and usually remain in your devices regardless of whether it is on or off. So those firmware, you won't be able to have access to them because they are already designed on the system. So they only execute their work whenever you on the system in terms of the booting and so on. Functions of ROM, which is known as read-only memory. So the primary function of the ROM, which is read and only memory, is data storage. So ROM refers to data storage. Any information stored in ROM chip can only be read and can hardly be edited by individual, except the main manufacturer will be able to have access to do so. But the good news is that data will be intact even after switching off the devices or when the power supply disconnected unexpectedly. So we'll be able to have access to our vital data and information even after the power is not available. But whenever we provide a power to the system, we'll be able to proceed from where we stop. So according to computer experts, ROM stores crucial programs needed during booting. So they are process that the ROM did secretly on the system. Like when booting, it also retains the strength of all those data and information of the system. It makes sure that they are intact on the storage medium. So let's take a look. Bottom line. In a nutshell, read-only memory, which is ROM, store important information that controls your computer fan and deleting peripherals. So what are peripherals? They are devices that are attached to the system externally. So this bottom line is typically referring to the visual element of the computer system. So the nutshell is an electronic device that receives input, process data, and provide output also. That's the essence of this nutshell. So the user or the system cannot edit the data, and unlike RAM, which is random access memory, the content stays recorded even after switching off the computer. So even though our system went off, our vital information or data that we save on the system, they are all intact. Encoder and decoder. So an encoder converts data into a code, while a decoder converts the code back to the original form. So let's look at the first one, which is the encoders. And decoders play an essential role in a digital electronics project. Encoder and decoders are used to convert data from one form to another, which we explained earlier, that the encoder converts data into code, while decoder converts the code back to the original form. So they are frequently used in communication systems such as telecommunication networking. Telecommunication networking are a means of transmitting data and information from the sender to the receiver. So let's look at to transfer data from one end to another, and similarly in digital domain for easy transmission of data. So the process of this transferring of information or data in this digital domain is a process of sending a message to individual which they were to receive, and also send the message back to the destination. So it is often encrypted or placed within the codes. So the encryption is a process that scrambles data into a secret code and then transmit at the receiver. So the coded data is decrypted or gathered from the code and is processed in order to be displayed or given to the load accordingly. Since we said that the encryption is a process that scrambles data into a secret codes, so that individual will be able to understand those codes. So let's look at types of encoder and decoder. So an encoder is an electronic device used to convert an analog signals to digital signals, such as a BCD. So this BCD refers to binary coded decimal. It's a system for representing decimal numbers using binary digits. So what are those binary digits, which are 1 and 0s? So it has a number of input lines, but only one of the input is activated at a given time, and also produce an end bit, which is the output code. So that depends on the activated input. So let's look at the other one, which is the decoders. So decoders are used in many electronics projects to compress the multiple numbers of inputs. As we said earlier, they have multiple numbers of inputs which are represented by binary digits. So multiple numbers of inputs into a smaller numbers of output. The encoder allows 2 power n inputs, which is the input, and generate n numbers of the output. For example, 4-to-2 encoder, if we give 4 input, it produces only 2 output. Let's take a look of this BCD, binary coded design diagram. So let's look at our left hand side. We have 2 raised to the power n inputs. So our input, we have 4 input here, but we are saying 2. In order for us to have 4, we have to take this n to make it 2 raised to the power n. It will give us 4. So this our input should be our output also. So we are going to have 2 output and 4 input. Since we have converted it to 2 raised to the power 4 is 2 raised to the power n is 4, then the output should be 2. So this is the encoder design.